Okay, sorry guys for being slightly late. I'll just enable the attendance first. Hmm, attendance. Attendance is enabled for IT plus and CSAI plus. Okay, done. Yeah, so attendance is enabled, guys. We'll wait for 2 more minutes, okay? Okay, so I think we should start. Maybe others will join in. So there are two things that were left on the last meeting: friends function and virtual functions. So we'll just complete that first, and then I have added two lectures about, I think, what, 2.5 hours back. So yeah, I know most of you may not have seen it. So we will discuss that aspect of the syllabus, that is basically multiple inheritance. Now, we also have to do something related to projects. So as of now, what I plan is that let us have another meeting tomorrow, and there I will talk about what I what I feel you could do in the projects. I know that we don't have much time left, so whatever you can do in about a month's time. So the projects will go on in parallel with our classes and labs. So just try to schedule a meeting among yourselves once in a while. Let us say once, twice in a week or something like that, and try to work on the projects as well. Okay, but we'll talk about projects tomorrow. So let's go through friends function and virtual functions first, and then we'll come back to today's lectures that I've uploaded. By the way, any queries till now? Any questions? Till whatever we have covered already. I do know the things are not really going in the way we should have. We would have ideally liked them to. Uh, but yeah, and yeah, the labs I'm trying to get in touch with the TAs. So we will be, I mean, as of now, I plan to have at least one practice lab this week. So you'll sit with your mentors for 2 hours and try to solve a problem, right? This will be a practice lab. It will not be evaluated, but at least you can start writing some code in C++. I mean, I know you guys already write a lot of code in C++, but related to whatever we have covered in the course. So I will try my best to arrange a lab this week, the coming week. I'll have to talk to the TAs. I'll have to know who all are fit and who all are not. So based on that, I may have to assign some of you to some other groups temporarily because if your TA is not well. So I'll talk to the TAs tomorrow and figure it out. But this week I intend to have at least one practice lab. Okay, if there are no questions from the previous meetings, then shall I continue? Okay, let us start then. So, till last time, what we saw was friends. We stopped right before friends functions. So one of the things that you should know, and this is a rule of thumb, that private fields are never accessible to anyone outside the class, right? It not the derived classes, not the not the main function, nowhere, right? So private means absolutely private. They are not accessible to anyone outside the realms of the class. So now, how in some peculiar cases you might want a particular non-member of a class to get access to some private members of the class, or they would like to use these private members in certain fashion. So how can we do that, right? Of course, the first option is to make it public, make those members public, but that certainly is not really a solution. Okay, it is not good to make something that is private to the class as public, right? So that is not really a solution. So the other solution we have, this is specific to C++, by the way. I don't know whether friend functions are there in other languages or not, but in C++ you have this option of creating a friend function, or by extension a friend class. Okay, so what exactly is a friend function? So let us have a look at this class. Sorry, what is it? Uh, Yeah. So this is that battery operated toy class that we saw last time. And here you can see that there is a function declared as friend. Okay, friend void repair toy. Right. So what exactly is the idea here? That there is a toy object, of course, and the repair toy function is going to perform some kind of repairing, right? So you'll have to provide it access to the private members of repair of any battery operated toy. So in order to do, but keep in mind that this repair toy is not really a member function of this particular class, right? It is a function that is outside the realm of the class. It's a normal global function, and you want this function to be able to access the private members of this class. So how do you do that? So first of all, you put this friend keyword. Any questions? Okay. So the first thing you do is that you put this friend keyword. Okay, this is a keyword in C++. So you put this keyword in front of the function's prototype, and then you put it in the class, right? So this something like this. So this is interpreted as this repair toy function is a friend of this particular class, battery operated toy. Now what happens again, the definition is very similar to how you guys have already been doing it. um, this is where I declare the function also, and here um, it is not always required, but it depends on how you are adding your code to the at the time of make. But this is a good idea. This is known as forward declaration. What does forward declaration means? Let us assume there is a situation where there are two pieces of code which are actually accessing each other, right? So let us say there are two classes, class A and class B, and there is some kind of linkage between them, that class A is having a method which returns, let us say, an object of type class B, and class B has let us say a field of type class A. So now it doesn't matter how you declare them, right? I mean, um, in either order, whether you declare A first and then use it in B, or whether you declare B first and then use it in A, you'll see that either of the two cases, the compiler will not know what exactly is the other thing, right? Because it has not yet seen any declaration for the other member. So wherever you have this kind of cyclic references, one way to resolve this problem is known as forward declaration. So here all I'm saying is that there is a class called battery operated toy and then a semicolon. So this is a declaration for this class. There is no details provided here, right? And then after that, I can declare the prototype of this particular function, repair toy. Now, when the compiler actually compiles this code, it knows that, okay, somewhere down the line later, I will encounter the battery operated toy class. But yeah, for now, let us just compile this function, and I am going to assume that this function will take a argument of this particular type. So this is the declaration for our friend function, and then definition is like this. It's a global function. It is not within any particular class. It is directly inside the namespace, and the thing that you can do here is something like this: toy dot in underscore use. So this in underscore use is a private member of battery operated toy class, but you can access it within the friend function. This will not have a problem, right? So this is a peculiar case where you would like a particular class's private members to be accessible to someone outside, so you can declare that function to be the friend of that class. By extension, let us say you have by the way, these friend functions need not be these global functions which are outside all the classes. Okay, it could, for example, be a function, a method which belongs to any other class as well, right? So as I said, right, let us say there are two classes, class A and class B. A member function of class B could be a friend function of class A, right? So that is also possible. It's just that when you give that friend declaration, at that time you will have to give the fully qualified name using the scope resolution operator. Okay, any questions related to friend? I mean, and by the way, extending the analogy, if you want all the private members of a class to be accessible to all the member functions of another class, then you can also write friend class B, right? So basically, instead of just a particular method, you can also make a whole class as a friend of another class. Remember that in this case, it will not I mean, this is a one way relationship. Okay, it's not like A can access all the members of B. Okay, but B can access all the members of A. So this is a one way relationship, not a two way relationship. Okay, any questions on friend functions or friend classes? See, the reason I'm talking about all these things is because if you start reading C++ code from different libraries, you might see these things being used. Okay, friend functions and but otherwise, if you are writing your own code from scratch, and if it is possible not to use friend functions and the topic that we are going to discuss today, multiple inheritance, um, try to write your code without having these things. Okay, so these are certain language features that are there in C++, but from design perspective, friend functions are not really something that are good, right? I mean, it makes your uh, analysis very difficult because there is it's friend functions are like intruders for a class, right? You are expecting that if something's going wrong with a particular object, it can only happen at certain places, but then you forget, okay, there is a friend function too, who can change the private members directly. So, from the perspective of design, from the perspective of analysis, friend functions are not really that great. So, but you will find a lot of friend functions in the code that any open source C++ code that you will see. There will be friend functions. So that is why I just gave you the idea of what friend functions are. Any questions? Okay, so there's one more thing from the previous meeting that we did not talk about. So let us let us have a look at that as well. So these are virtual functions. So let us go to the toy class again. Now, I think, give you guys an idea of what overriding is, right? So the overriding concept means that let us say there is a particular method in a particular class. Again, let us take the example of A and B. A is the base class and B is deriving itself from A. Let us say there is a method which is there in class A, but there is a possibility that derived classes of A may not find this version of the method to be complete, or they might simply want it to be completely removed and replaced with something else. In such cases, we are allowed to provide a new definition for any methods that were there in the base class, and the way to do that, the proper way to do that, is by putting the keyword virtual, and this you have to do in the base class itself. So right at the top of the hierarchy, you will have to inform that this is a kind of a function for which there can be different definitions at different levels of inheritance hierarchy. And in such a case, the compiler knows, okay, so there is a possible override available for this particular function. Okay, so here what we are doing is we have these two methods, start playing and stop playing. You can see how they were implemented in the toy class. So this is how they were implemented in the toy class. There is just a message that you are now playing with this toy, and which is having this ID, and this toy with this ID is lying idle. So this is how we defined it in the toy class. Now let us say when we implemented this battery operated toy, there is an additional thing that we have to do, right? So for example, a battery operated toy cannot be played with if the batteries are not yet installed, right? So there is an additional check that you want to put in. Okay, so that is why this is why these functions which have been declared as virtual we can provide a new definition for them in the battery operated toy class as well. Where is it? Sorry, it is not. So here, here. Okay, so what do we do here? So we basically see whether this particular toy is currently ready for playing or not. So this flag is ready for playing. This method will give you true if the batteries are installed. If they are not installed, then it will return false for you. So when you try to do start playing, basically the first thing it does, it checks whether this toy is playable or not. If it is, then it basically says I'm switching on the toy so that you can play with it, and then it calls that same implementation that we just saw, right? So in this case, it is truly a case of extending the behavior, right? I'm not overwriting the behavior. So the start playing from the toy2 class is also being used. It's just that I want to add something more to it. So I wanted to add some logic so that this function is only called the base class version is only called under certain conditions, and otherwise you simply put out a message saying this toy is not yet ready for playing. The same thing is there for stop playing. You basically check that if this toy is currently being played with, you simply do in use equal to false, you switch off the toy, and then you print that same message that was there in the base class version. So this is a way to extend behaviors from base classes to derived classes. Okay, you can still access the base class versions. It is not necessary, by the way, to call these two base class versions. You could uh, have done something else here. It is not required to do this. It's just that many a times you will find it useful to be able to access the base class version and add some logic over it in the derived class. So this is how you do it. You do it using the scope resolution operator. Any questions on this, on virtual functions? So virtual functions are basically the overall idea is these are the functions which may be, again the question, the point here is maybe, which may be redefined in the derived classes. If they are not defined, then it is fine. But so then the definition that is applicable is the definition in the base class. But they may be redefined in derived classes, and in which case the compiler will know that okay, I have to invoke this particular definition and not that one. Okay, any questions on this? If there are no questions, then I'll move to the parts for this week, the next week actually, and that is the overall idea is multiple inheritance. So let me just stop this and go back to a presentation. By the way, this lecture I have also recorded and put it only a few hours back, so you can of course go back and check it out. I knew not many of you would have seen it, so it's okay. We'll cover it from the scratch. Okay. Hmm. So whatever we have covered as far as inheritance is concerned till now is actually known as single inheritance. Okay, and we'll now start with something known as multiple inheritance in this week, in this lecture. So let us just revise whatever we know till now. So you know that private members of the class are not inherited. That is why we needed that protected access specifier. So protected is essentially it is it is like private to the rest of the world, and it is like public to the derived classes. So basically protected members are inherited, but private members are never inherited. And if a particular method, as we just talked about, could be re-implemented again in derived classes, then we should create that, we should put this virtual tag in front of that method in the base class itself. Now from there onwards, whenever there is a redefinition of the function, it basically overrides the definition of the base class. In the base function, in the base class, if you do not provide any definition for this function, then this is known as a pure virtual function. And we've seen the idea of what a pure virtual function is. So essentially the derived classes then are forced to give a definition for this, otherwise the classes become abstract. We also know that there can be a hierarchy of classes where one class which is a derived class in some respect becomes the base class in another respect. So this is an example that we started off with, that the pizza, for example, is in the middle of this hierarchy. So it is a derived class with respect to the wheat based dish, and it is a base class for this onion and tomato pizza. So this whole hierarchy that we created, right? The idea was to build an application in such a way that the specialization and generalization relationships between entities, they are preserved. Okay, so whatever is there in the real world, they are preserved in some ways. So a typical example is that basically we say that pizza is a type of wheat based dish, and an onion and tomato pizza is a type of pizza, right? So as you move from top to bottom in the hierarchy, the the things become more and more specific, and or let us say more and more specialized, whereas if you move from bottom to top in the hierarchy, things become more general. So now till here we have seen that for a particular class, even though there can be multiple derived classes from this particular class, you saw that wheat based dishes had at least two derived classes. Pizza also had two derived classes. So there can be multiple derived classes from one class, but till now we have seen that for a given class there can be at max, at max one base class. This is what we have seen till now. Okay, and such a kind of inheritance scenario is also known as single inheritance. So single inheritance means that each class in your application has at max one base class, not more than one, right? So and you can see that why it is a nice thing to have as well, right? Because all those generalization and specialization things that we have been talking about, it makes real sense when you have just one parent, right? But there is another way of designing a system where you basically make two classes as two or more classes as parent of one class, okay, as the base class for one class, okay, and this is known as multiple inheritance. So this is a real world example. I'm not making this stuff up. This is a real world example. There is something known as burger pizza. Okay, it is provided by Domino's, and if you try to understand what exactly is a burger pizza, I really don't know. I don't really want to taste it either. But yeah, a burger pizza is essentially a burger plus a pizza. So one way to look at it is that a burger pizza has two base classes. There is a pizza class and there is a burger class, and it inherits stuff from both of these, and that is why it is called a burger pizza. I think you might not be able to see this because of this. Just a minute, right? Okay, so this is what a burger pizza looks like. It is inherited from pizza as well as burger. So now this pizza class has two base classes, okay, and this is known as multiple inheritance. Now, to be fair, I'm only teaching multiple inheritance to you so that you understand what it is, and so that you understand what are the drawbacks of using multiple inheritance, right? Um, from the perspective of design, um, take it as a kind of a thumb rule that you should try to avoid multiple inheritance to whatever extent it is possible, right? Why? Because multiple inheritance can make class diagrams or relationships which are really complex, and they are not easily interpretable. Okay, so multiple inheritance is actually a controversial topic. Okay, many people believe that the languages should simply stop supporting multiple inheritance at all, right? But in fact, Java does not used to support multiple inheritance at all. I only recently, when I started preparing this lecture, came to know that in from Java 8 onwards, they have provided one way in which multiple inheritance can be achieved, and this has meant that they are now prone to the diamond problem. We'll see what a diamond problem is. But prior to that, Java was basically safe from this multiple inheritance related issues. So the idea is that you should, if and Java is used, by the way, to build a lot of systems. So it is certainly possible to build your system, to design your system in such a way where you do not need multiple inheritance. But because in this semester we are studying C++, and C++ provides you support for multiple inheritance, so we should have a look at what this whole thing is all about. So, again, one of the drawback that is there is that these specialization and generalization relationships become slightly complicated, because now just saying that burger pizza is a type of pizza is kind of incomplete. You should say burger pizza is a type of pizza as well as a burger, right? So now this is why it becomes a little trickier to understand. Okay, so whether it is pizza, whether it is burger, what exactly is it? How to whatever is it, it becomes difficult to analyze. So anyhow, so this is one of the problems with the with multiple inheritance, that you find it difficult to visualize how your classes are working in the real world. So as an example, assume that there is a property or behavior. This is an example of why you should not use multiple inheritance. So just try to imagine in a particular scenario where you have some property or behavior which is common in both base classes. Okay, let us take the example of this A, B, and C again. You have class A, which has, let us say, a field called int I, and then you also have another class which has, let us say, class B. It also has another field called int I, and now you inherit both these classes to into class C, right? So now there are and assume that int I is in the public or protected zone, so that it can be inherited by C. Now the question is, where does it land up? What exactly happens to this int I inside C, right? So no, whether there are two copies of I, whether there's only one copy of I, what really should happen, right? I mean, whether we should have both, whether we should have just one, what exactly happens, right? So let us take this example, that assume that pizza class had a type, had a field called type, which was basically an enumeration on short pizza, regular pizza, or large pizza. And burger class also had an enum, which was basically short burger, medium burger, or large burger. Now the type field, okay, it is the name is the same. So if I inherit it into burger pizza, what really happens to type? Do I have two types here? Is it just one, or none? What happens really? So this is a problem with multiple inheritance, that if you have um, two or more members of exactly the same name, how do we handle them? That is the issue. So the solution to this is ideally left to the makers of the language, right? So for example, in this case, it is left to the people who built C++. They have to deal with it. They have to figure out whether all the members should go in, whether only single member should go in, whether the user be forced to tell me which of these two should go, so on and so forth. So whatever it is basically left to the language implementers to figure out how to deal with this. Okay, there is really no straightforward way to deal with this problem. But you'll see that in one particular case, one peculiar case, this problem becomes even more interesting. So this is known as the diamond problem. So let us do this. The type variable that was there, the type member variable that was there in these two classes, let us rename it, right? So let's call the one in pizza to be p underscore type, and the one in burger to be b underscore type, right? So now the problem is resolved. Now I have two different variables, two different member variables, and they can both be inherited easily by my burger pizza. Of course, it doesn't matter, but it is possible that burger pizza doesn't use either one of them, because ideally it may not suit it. But now the from the perspective of a language implementer, or from the perspective of writing code, I think I'm fine, right? As long as there is no clash between the variables, things are fine. But now let us, extend this inheritance, which was basically a kind of single level inheritance, where there was one class which was inheriting from two class. There is basically a single level of inheritance. Now just extend and expand this inheritance to another level. Okay, so let's just say that this pizza and burger class also have a base class, a common base class. Okay, and this is, let us say, called the wheat based dish, because okay, burger have buns, and these buns are also made from wheat. So now this makes this problem slightly more complicated. Why? Because whatever pizza and burger inherit from wheat based dishes, these members are now become a part of pizza and burger classes. And when any class inherits pizza as well as burger, these members are also going to travel there, right? Provided that they have not been put in the private section. So these members are also going to travel to this new class that you are going to create, that is, let us say, pizza burger. So what you really have is something like this. It is like a diamond. there is one base class, then there are two derived classes, and then these two derived classes become the base class for a fourth class. So it's like a diamond shaped inheritance scenario. Okay, and this is known as the diamond problem. So let us say here, um, this there is a type thing which was declared in okay, sorry, this is not burger pizza, this is wheat based dish. I'll have to change the slides. Yeah, so this is the idea. Sorry, that there is there is something coming from the base class of these two parent classes, and if this particular member travels to this particular class, how will we manage this, right? Because now we cannot rename it. Renames can be done only here. Okay, if it is coming from a higher class, how should we handle it? Because the same member will be here, the same member will be here. So this is known as the diamond problem, and diamond problem is one of the strong reasons to avoid multiple inheritance, because in such a case what will happen is the members of your base class at the top level will anyhow come to the members will anyhow come to the class at the bottom level, and now you have to figure out how to deal with it. So in C++, they do have a specific mechanism by which you can make sure that only a single copy of the values coming from, let us say, the wheat-based dish class is maintained in Burger Pizza, and there is this way to do that. We'll just cover it up right now. But any questions till now in order to understand what the diamond problem is? It looks like in this particular course, I think I do not get the kind of feedback, because probably it is more theoretical as compared to ITP, or maybe you guys have already studied it. I don't know. Uh, you guys have studied C++, so it could be that you already know all these things. So this may be another reason. But you have to understand that from the perspective of your overall growth, all these concepts are important. Okay, so at some point of time you will have to learn all these things. It is of course better to learn it when you are being taught. Anyhow, any questions about diamond problem or multiple inheritance as such? Okay, so if that is fine, so I'll just show you now that how multiple inheritance is done in C++. Instead of going to the presentation, I'll actually take you to the code part, because if I know I feel that sometimes you guys are happier seeing the black screen with green and and blue and white text over it, rather than seeing a PowerPoint presentation. So I'll just show the rest of this lecture to you in the virtual machine that I have. I just hope it is more interesting than whatever we've had till now. Just a minute. Okay, I hope you guys can see it. So let us see. The first thing that now we are going to do in order to show you an example of multiple inheritance is something like this. Let us say you have these some of these toys are like drones, right? I mean, which can fly, at least not too high, but maybe a few feet high. I do know that there are some kind of working models that are available in the market, which can fly to certain heights, not too high, but maybe a few feet of height. So, these models of planes. Uh, okay, Shashwat, let us hope so. So this is why I am also going to have a practice lab this week, because I feel it's like everything is has fallen in some kind of a rut. Okay, maybe because of the 15 days break that I had to take. Um, Maybe because it is certainly not as interesting as ITP, because here there are probably 50% of 50% concepts and only 50% code. So yes, it becomes difficult sometimes to maintain your concentration if the things that you are being taught are not really that interesting. And then I of course hope that when you guys try to do something. Okay, so and plus when you try to plus, but please don't order that burger pizza. Okay, it looks horrible to me. I really don't know what exactly is it, what are they trying to achieve. But you can see, right, when you use multiple inheritance, something horrible happens. So I hope that burger pizza is also something horrible. um, uh, okay, is it? Okay, okay, okay. Okay, okay. So there are just like multiple inheritance, people are divided whether we should use it or not. Uh, so so yeah, that is exactly the same with multiple inheritance. Some people feel that it's awesome, that we can have two base classes for the same class, and while others, like people like me who are more, kind of uh, people who believe that single hierarchies are much better for analysis. We believe that multiple inheritance should not be used. So anyhow, burger pizza is a good example that it looks horrible to me. I don't know, it might be good in taste, but the idea seems to be horrible to me. Pizza and burger are two very different things, and we should not, but yeah, some people like fusion stuff. Anyhow, so yeah, so let's go back to the example. So let's just say I had to manufacture an example because I never use multiple inheritance, so I had to manufacture an example for you guys. So let's just say that these are the toys of these type, right, which basically fly. Okay, and what kind of toys can fly? Let us say a flying disc. Okay, what do you call it? Frisbees, right? So frisbees fly as well. Okay, but they don't really have any wings. Okay, and then you can have a helicopter which has like a single wing. There can be a plane which has, for example, two wings or four wings or whatever it is, right? So the first thing that did was I created a class called flying toy. So this is the class flying toy. Okay, so it is essentially just forget the virtual part for now, but just look at this part. So basically, it is extending the toy class that we already have, and it is just adding one more field to it, the number of wings it has. Okay, the number of wings could be zero, for example, for something like a frisbee, or it could be one for something like a helicopter. It could be two or more for, let us say, a plane, something like that. So this is one property it is adding to this hierarchy. And then the same start playing and stop playing methods, it is re-implementing them. So these are being overridden here. And then there is another method called has wings. So does it have wings or not? That is the idea. And so this is a class called flying toy. And similarly, the battery operated toy, I have only made some small changes, but it is exactly the same as other than some virtual keyboards. It is basically exactly the same as what we have done, as we have seen in the previous case. So basically, there are a number of batteries. The batteries are installed or not, whether it is being used or not. Start playing, stop playing, put batteries, everything. Even that repair friend function is also there. So now, if you try to see what exactly would a toy called, let us say plain toy, okay, I don't know what should I call it, whether I call it drone or whatever it is. But for now, I've just named it plain toy. So a plain toy is simultaneously a flying toy because it flies, as well as it is a battery operated toy, right? It has batteries in it. So now this is an example of multiple inheritance, that this plain toy is inheriting properties of both flying toy as well as battery operated toy. So this is an example of multiple inheritance, that I'm going to inherit both these classes within plain toy. And it is just adding one more field to it, the model name. So for example, this is a model based on Airbus A380, let us say, something like this. Okay, or a Boeing 727 or something like that. So this is a model this is a field that this particular class is adding. And then whatever fields are coming to it from flying toy and battery operated toy, that of course is also a part of this particular class. So an example of uh, this is an example of multiple inheritance. So let us for a moment forget that flying toy and battery operated toy are also inheriting from the toy class, because the moment we go to that level, we'll understand that this is
You are inaudible.
Okay, I'm not sure. Okay, can you guys hear me now?
Yes, sir.
Yes,
Yeah,
sir.
and
Yes,
yeah,
sir.
yeah, but I'm not the presenter anymore. I'm not sure who became. I guess uh
Anukul, sir. Anukul is present.
yeah, yeah, Anukul, please make me the presenter. Okay, thank you, Anukul. And let me show you. This is the weirdest thing about WebEx, right? I mean, I'm just showing you this in order to see. Okay, this is my internet speed all this while. Okay, and still, I mean, I was able to chat with you. I was able to share the screen, but the voice was not going through, right? So this is just WebEx for you. Some days it just decides that you've spoken enough. Anyhow, so let me reshare the window. And I still don't know why they can't buy Google Meets license. Okay, anyhow. Yeah, so you can hear me as well as see the screen now, I hope.
Yes, sir.
Okay, so yeah, so let's go back to the flying toy example. So basically this plain toy is a class that is inheriting from two classes, the flying toy class as well as the battery operated toy 2 class. So now in C++, there are a number of ifs and buts in which you can use multiple inheritance. Okay, the first thing is like this. It will not raise an alarm even if these two base classes have some conflicting data members. So, okay, so it is possible that both of them have a field which is of exactly the same name. C++ will not object to it unless you try to access it. Okay, if you are not going to access it, the compiler will have no problems. Okay, but if you want to access it, then the only way you can do it is using the scope resolution operator. So if you go back to our simpler example, class A and class B, they both have int I as their field, and then class C is going to inherit both A and B. If you want to access the I variable, you cannot simply do I within C. Okay, that will raise a problem. That there will be a compilation error. The compiler will tell you, I really don't know which I are you talking about. So in that case, you'll have to use A, scope resolution operator I, or B, scope resolution operator I. So basically you will have to make it unambiguous for the unambiguous or whatever it is. I still don't know what is the right word. It's a word that I'm using after a long time. So you have to basically remove the ambiguity. Okay, the compiler cannot work with ambiguity. You have to tell it explicitly which I do I want. I want to use the I coming from A, or I want to use the I coming from B, or you simply don't use I at all. If you don't use I, then compiler doesn't care. Okay, but if you are going to use I, you will have to use the scope resolution operator and tell the compiler this is the version of I want to use, and then everything is fine. Okay, so this makes one thing absolutely clear, that in the background there are two copies of I being maintained, one for A and one for B. So the same thing happens here, that in the background, if there are two sets of fields which are exactly the same in both flying toy as well as battery operated toy 2. Yeah, so right now I was not typing anything, sorry. um, Sorry, I was just trying to explain it. uh, okay, so um, let me open CPP. So if you do, I should have actually made another example maybe. The idea is, if there is anything that is coming from flying toy as well as battery operated toy, and if you, I may have some temporary things somewhere. I too was trying to see how exactly the modern day compilers work. So maybe I have something here, temp or test or something like that I had created. Is it? Yeah. Okay, yeah, I do have this. So I was trying to see how are the current day compilers working with it. So basically, let us for a moment remove X from here. I have this class A, and huh, yeah, I think that should be it. Right. Let me just compile this thing. It goes through. So now let me just show you what I have just done. I have two classes, class A and class B. Okay, just don't ignore this commented part. For now, just assume there are two classes, class A and class B. There is a field called I in here, in both of these classes, and then I'm inheriting this in class C. Right now, in the class C's constructor, again, this the same thing I'll have to do as I have done with single inheritance, that I'll have to call both these constructors. Right now, instead of just one constructor, I have to call two constructors. If it was just public A, for example, I'll have to do it like this, like AI only. Here I'll have to call them in some order, whatever order I want. The order is not really a problem, but I'll have to call both constructors of A as well as B, because A and B do not have a default constructor. That is the problem. If A and B had default constructors, this part was not required, but because they don't have default constructors, I will have to explicitly pick some constructor to be invoked. So here you can see that I am basically passing this I'm using this I variable. So the I is coming from both these places, B as well as A, but the code compiles without any problem, right? The compiler doesn't care as of now, right? Why? Because I have not yet accessed I, but the moment I try to do this, I is okay. This too might work, because this I will be actually local I. Let me try to put a function here, maybe. Okay. Void print I, cout I is I. Okay, and then I close it, and then here I try to call it. C dot. Okay. Now if I do this, this is what the error says. Okay, you can read it for a moment. Okay, what does it say? A reference to I is ambiguous or ambiguous, whatever you call it. Okay, I'll have to check how it is pronounced. And why it also tells you that there are two candidates. It is either B, scope resolution of operator I, or A, scope resolution operator I, right? So it says that I have two I's within the object C. You have to tell me which of these two I's are you interested in. So the moment I do this, then it is not going to be a problem. I can do I I's values are, and then you can say A colon I, and B colon I. And now it should not have a problem. Okay, so you can see what is happening here. Any questions still here? Thank God I'd actually created this example just to see how the modern compilers give the warnings and everything. I remembered that it is there in my temp area. But is this part clear, that basically both copies of I are going to be maintained in the object of C? As long as you don't access it, compiler doesn't raise any alarm, no compilation errors. But the moment you try to access them, it needs scope resolution operator. Without that, you are going to get an error. Is this part clear? Any questions here? Okay, so if this part is clear, let us go back to our flying example or whatever it was. So now you know that this in this flying toy, plane toy example, what is really happening is diamond problem, right? Because both flying toy as well as battery operated toy 2, they are inheriting from toy 2. So now anything that starts from toy 2 and reaches plane toy, there will be, number one, there will be two copies is not a problem, that we have already seen. All that you'll have to do is you'll have to use the scope resolution operator. You can say flying toy scope resolution operator this member, or battery operated toy 2 scope resolution operator this member. So copies are not really a problem. Of course you'll have to make it unambiguous, but the major issue is logically it is wrong, right? Because the same copy, it is basically the same variable, right? It traveled from toy to flying toy. It also traveled from toy to battery operated toy 2. And now in this plain toy, there are going to be two copies of this variable. It doesn't make any sense, right? So the way to do that in C++ is, while you are inheriting these two classes, battery operated toy 2 as well as flying toy, keep this in mind. This has to be done at these two levels. Okay, not at this level. So basically in the diamond problem, it has to be done at level 2 and not level 3. Okay, so the two class level, you have to do something like this. Just put a virtual keyword here. So basically you are not inheriting from toy 2 straight away. You are basically saying I am inheriting from toy 2 virtually. What it really means is, there is a chance that we are going to get involved in a case where this particular class toy 2 can be reached twice in the class hierarchy, in which case please only keep a single copy of toy 2. The same thing I have to add in the flying toy. Here also I have added the virtual keyword. So now once I do this, now what happens is, when I create this plain toy, here the members from toy 2, only a single copy of those members are being maintained here. Okay, does it make sense? Now the compiler already knows that toy2 is going to appear twice in the class hierarchy for plain toy. So it figures it out that these set of members are being duplicated. So it only keeps a single copy for them. Is this part clear? The only thing that is changing is you don't inherit straight away, you basically inherit virtually. And then if after inheriting virtually, these two classes or more than two classes become the base classes for the same class, compiler makes sure that the there's only single copy of the variables from the base class. Okay. And there's one more thing that you now need to do, because what happens is in case of simple inheritance without any diamond problem, without any virtual inheritance, what happens is that constructors are called from base to derived order. So if you have a 3-level hierarchy, the constructor of the class that is at the top gets called first, then the constructor of the class at level 2, and then the constructor at the class 3, level 3, right? So the same thing cannot be done now. Why? Because otherwise the constructor of toy class will be called twice, because once you will reach it via flying toy, another time you will reach it via battery operated toy. So now what happens is something like this: the way constructors are called also have to be manipulated. So what we have to do is something like this. In this constructor of plain toy, what happens is the toy constructor, okay, the flying toy constructor is called, but that colon and whatever you do after that, right, that part is not executed. Similarly, battery operated toy, this constructor is called, but whatever is there in the header after the colon, that part is not executed. So the major problem is how do you you know first create one object of toy2 and then use it with these two objects of flying toy and battery operated toy. This is the problem. Now if toy2 had a default constructor, this part was not required, but because toy2 does not have a default constructor, if I remove this part, you are going to have a problem. Okay, so you will get an error saying that I do not know how to create the constructor of toy, how to create an object of toy2. So this is why this constructor becomes even more complicated. Not just so not only do you have to call the constructor of parents, this is the terminology we often use, these are parents for plain toy. We also have to call the constructor of the grandparent, okay, the grandparent in the diamond. So you can already see it's getting really really complicated. And this is why, as I said, right, if the best way to win a war is to not fight it at all. So that is the idea, that if you want to if you want yourself to be out of this mess, try to do your designing in such a way so that multiple inheritance does not get involved. And this is like the crux of the matter. I have taught you this because it is a language feature. If you start reading C++ code, you will see all these things, so you should at least know what is happening. But if you are building your own systems, designing your own systems, try to avoid multiple inheritance to whatever level it is possible. Any questions now?
Sir, what happens if there is a function? It is not related to multiple inheritance, but what happens if there is a function with the same name as the one in the base class?
Hmm. So in
So
fact, it is
is that
happening here. In fact, it is happening here. This start playing and stop playing, right? Let me do
yes,
this.
sir, yes, sir.
Yeah. So let me do this. In fact, I'll just comment it for now here, okay? And I will remove it from the plain toy.h part as well. And let us try to compile this. Some plethora of errors have come up, right? So what exactly are these? Let us try to see. Let's go up. So the first thing it says is no unique final overrider for virtual void start playing, right? So don't worry about the final part as of now. The problem really is this: either plain toy has to be basically an abstract class. An abstract class is basically a class um, whose objects cannot be created. Okay, but here we are creating the object of this plain toy class as well. So what we have to do is really it basically says now there are two definitions for start playing, which one is coming via this and one is coming via this, and I really don't know which one to use. This is the problem that the compiler has. So now you are forced to provide some definition for these functions, start playing and stop playing, in the plain toy class. This is the problem, right? So because there cannot be two copies, there has to be a single copy. If it was not virtual, then everything was fine. You could have accessed the start playing version from flying toy using the scope resolution operator, and the start playing version of the flying toy of the battery operated toy again using the scope resolution operator. But because the inheritance here is virtual, now you are forced to provide a definition for start playing and stop playing within the plain toy class as well. Okay, the idea is nothing can be ambiguous. That is the idea. Wherever there will be ambiguity, the compiler is going to force you to make it unambiguous. That is the only idea. This is the thing that you'll have to put in mind, that whenever you are trying to analyze C++ code in terms of multiple inheritance, just try to think like a compiler. Just try to think that if this is told to me as a compiler, is there any ambiguity? Is there a way in which I can uniquely identify a particular variable or a particular definition? If I can, then the compiler will not have a problem. It will go through. If you cannot, from your mind you cannot, then clearly the compiler will not be able to do that as well. So you will get an error. Okay, so now if I add those definitions, these errors will go away. Okay, so that error has been removed. Now why? Because whenever I do start playing and stop playing, I don't have a problem, because I'm calling it from this place, for example.cpp. So here the compiler says, okay, now it has become unambiguous. I know which definition to call up. By the way, if I was not doing this, then the compiler would not have shouted. Okay, but because I'm doing this, the compiler has shouted. Okay. So the compiler is really accommodating. Okay, it tries its best not to perturb you, even in the case of multiple inheritance, to the level it is possible. But if you make it absolutely impossible for the compiler to run, it'll cry and it'll ask you to make it unambiguous. That is the idea. Any more? Is it clear? This is the
Yes,
problem
sir.
that so you have to remove the ambiguity. That is the idea. Any other queries? Okay, so I know this is really boring stuff, but you can also see that uh, from the perspective of design, it's very important to learn these concepts, right? Because otherwise you will end up creating burger pizzas. Some people will like it and some people won't. So try avoiding these kind of scenarios. Okay, try to create newer versions of pizzas and newer versions of burgers instead of trying to create burger pizza. Okay. So when you build some system, try to do your analysis in such a way that multiple inheritance is not required, and it is possible to do that, by the way. And in fact, this is where your engineering mind will be put to use. Okay, there might be certain situations where it becomes really difficult to figure out what should I do. So if let us say I give you the example of burger pizza, how will you manage it, right? how what is the way to represent it in real in class hierarchy without multiple inheritance. So this is where your engineering mind has to be put to use. You will have to figure out a nice crisp way, a nice crisp resolution to such problems. Okay, and this is what this whole course is all about, that given a designing problem, your mind has to run enough to be able to sort out the problem in an amicable way, right? uh, okay, any questions? We should have another meeting tomorrow. I'll give you more information about projects. Um, but other than that, any more queries?
So when I try to run these programs, I always need to change the hash include command. I always need to
Hmm.
include the plain toy.cpp or
Hmm.
uh, battery
Okay.
operated toy.cpp
Okay.
because it
Did you
says
use the make files or did you try to compile it using your own code or whatever, your own command?
uh, I
Try to
think I
use the
tried with my
makefile.
own.
Yeah, try to use
Yes,
the
I
makefile if you because in fact let me show you. The makefile has all these things available. The make commands there will have all the necessary files, right? So just have a look at this particular command, for example. Okay. This is just to build one executable. I am putting so many CPPs there, right? And there are so many
yes, yes.
dependencies, so many classes are required in order to in order to compile this code. So make this a habit. Okay, no one is going to teach you how to make files, by the way. This is a skill you guys have to pick up on your own. Okay, either you start building stuff in C++, then you will be required to know how make files work. Otherwise no one will teach you how make files work and how to make them. So please keep take it as a learning opportunity. Start using make files whenever you will be working on any open source product, whenever you are going to use um, any code which you are supposed to build from source in the Linux environment. You will have to bang your head with these make files. So the sooner you start, the better it will be, right? I mean, as of now, these make files are very simple. You can simply understand what is it. There will be make files which will be thousands of lines. So start using make files. It is another piece of learning that nobody is going to teach you explicitly. um, if you have again, with me, if you have a problem with make files, shoot an email and I'll tell you what exactly is what. But I want you guys to get in the habit of using make files. This is probably the cleanest way of building C and C++ applications. Okay, any other questions? Okay, Sen. So we'll meet tomorrow again. We'll have to decide some time. I think 5 p.m. is okay, right? If you guys do not have any that is what, Pranav. We'll talk about projects tomorrow, and please start forming your groups. Earlier, I was planning to have 2 people per group, but I'm not sure whether my TAs will be able to help me out in evaluation or not. If they are not able to, then I don't know whether I'll be able to handle so many groups. It'll be what, 115, 120 groups, right? So it's better to make it 3 people groups or 4 people groups. And so be ready with your groups. Talk to your friends who would like to work with you, and we'll discuss what will happen in projects tomorrow. Okay. Any other question? Acha, okay. So what time? I knew that you guys have these CP classes. So I don't know what is the timing. Please do tell me what time is better. I just sent an email yesterday for 5. I thought if you guys have any engagements related to your CP, you'll reply back. Then I realized nobody has any problem. But so what time will it be fine? Just anything before 5, anything after 5. I guess I get free around 3:30 or 4, and I am free up to 6:30. So from 3:30 to 6:30 I am free. So please tell me any time slot in between and I can take the class. It will not really be a class, it will be a discussion on project. Before 5. So 4 to 5 will be fine, guys. Right? So 4 to 5 should be fine. Akshay, please send an email to your friends. Tell them that at 4 we will have a project discussion thing. If anyone has any issues, they'll let me know. But please send everyone an email that it should not go up to 5. I think most probably we'll finish in 40 minutes or so. But yeah, 4 to 5 will be a better time. So please tell everyone, and we'll meet again at 4 tomorrow. Okay. And guys, please start some coding on your own. I know I'm not able to push you guys the way I did in ITP. But I'll have one lab, of course, in this week. But start writing this type of code. Okay, it's different. You can already see that this is a different type of coding. Okay, it is not really the data structure coding. This is system building coding, right? So please start with this thing. Come up with your own examples in your head that I have to I have to represent some real world scenario in terms of classes. Then you say, okay, this is the base class, this is the derived class, these are virtual functions, these are not non-virtual functions. This property should be private, this property should be um, as of now, try to keep it at 3, not less than 3. 4 is also fine with me. 3 or 4. Okay. Basically, the problem is I cannot evaluate so many groups. So it will be better if you because even 3 would mean what, somewhere around 70-80 groups. And if it is 4, then it will be less. So at least 3. It could be 4 also. Okay, because some of you might not be. Uh, I understand that the class is built up of different types of students, right? They have different levels of comfort when it comes to coding. So, and plus this is not just coding, this is also going to be analysis. Okay, so you'll have some fun. Maybe you can sit together and brainstorm. Okay, you'll pick up a problem, a bond, you'll pick up the problem of modeling some system, and then you come up with your own designs. You say that, okay, this design is better than this design, and then you argue that, you say, no, my design is better, and then you say, no, my design is better, and then you argue with each other why this design is better than this design. Okay, so this should be fun. I'm just guessing, but maybe my definition of fun is often not correct with everyone. So but I feel if you try to apply whatever we are studying here to some real world example of designing, it will give you a lot of confidence as a as a programmer. Not really as a programmer, as a system builder. You will learn how to build systems. Okay, that is one of my major if you can learn something on that line, that will be a huge victory for me as a teacher. So yeah, so that is it. We'll meet guys tomorrow at 4 unless there is some problem. So let us meet tomorrow. Okay, bye, thank you guys.